What exactly is the observable universe? The observable universe refers to the portion of the universe that we can observe and study using telescopes and other instruments. However, this capability is limited because light, the main source of information about the universe, can only travel at a finite speed. As a result, we can only observe objects and events that are at a certain distance from us. We cannot directly see objects or events that occurred long ago in the past. The diameter of the observable universe is estimated to be approximately 93 billion light-years, which is much larger than the estimated age of the universe, which is 13.8 billion years. This discrepancy is because the expansion of the universe has caused objects that were once close together to move away from each other, and light from those objects has required more time to reach us. Overall, the observable universe is a vast and fascinating space, but there's still much we don't know about it. However, through the use of telescopes such as NASA's James Webb Space Telescope and other scientific instruments, we continue to learn more about the structure, composition, and history of the universe, as well as its various phenomena. Join us as we discover the new structures that the James Webb Space Telescope has just made contact with in the far reaches of the observable universe. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Now, what lies beyond the observable universe? To reach the far reaches of the observable universe, we would need to develop transportation methods that would allow us to transcend space-time, such as using distortion engines or wormholes. These concepts have long been the subject of debate among scientists, some of whom believe that these are simply impossible or contradict the idea of faster-than-light travel. The feasibility of both possibilities, faster-than-light travel and the use of advanced technology beyond the reach of current human intelligence, is a subject of intense debate. Even if it were theoretically possible, it would require technological advances and machinery that are currently beyond our capabilities. The theory of cosmic inflation posits that the total size of the universe is at least 10^2^3 times larger than the observable universe. This number is so vast that it is incomprehensible to the human mind. Since we cannot see or measure the unobservable part of the universe, we have no way of knowing with certainty what lies beyond its limits. However, that does not mean we cannot develop theories based on the information we have gathered from distant galaxies. This is where NASA plays an important role. NASA, in collaboration with other space agencies and research institutions around the world, has made numerous significant contributions to our understanding of the universe. Even before the James Webb Space Telescope became operational this year, NASA had already released images of the ultra-deep field obtained with the Hubble Space Telescope. However, when the James Webb Space Telescope made its debut, it was taken out to observe the most distant galaxy ever recorded. These images revealed the presence of numerous galaxies shining in the distant cosmos, apparently as they were millions of years after the Big Bang occurred approximately 13.8 billion years ago. The expansion of the cosmos causes the stretching of light to redder wavelengths, which allows the James Webb Space Telescope to detect infrared light. This has allowed us to observe galaxies forming in the early stages of the universe's history. The James Webb Space Telescope has made observations of several fields of distant galaxies, allowing scientists to study the rate at which stars formed in the early universe. This data reveals the existence of a significant population of galaxies that were forming stars in the early stages of the universe. These discoveries are truly fascinating and thought-provoking. For a long time, humans have contemplated the possibility that we are not alone in this vast universe. However, these new determinations within the observable universe lead us to believe that there must be millions of galaxies in the unobservable part of the universe. This idea is truly shocking and awakens a sense of awe and wonder about the vastness of the cosmos. Are there extraterrestrial beings somewhere in the universe? The likelihood of life beyond Earth has never been more compelling, leading us to consider the possibility of the existence of extraterrestrials. There are numerous planets outside our solar system, known as exoplanets, which have been discovered using techniques such as the transit method and the radial velocity method. Some of these exoplanets may have similar characteristics to Earth and may harbor life. This theory has been supported by another discovery made thanks to the James Webb Space Telescope, related to the exoplanet WASP-96b. This planet is outside our solar system, and its light spectrum reveals something surprising: the presence of water molecules. In addition, the spectrum also shows hints of haze and clouds, which were not previously thought to exist on a habitable planet. Based on the habitable environments found elsewhere in the universe, and considering the advances in the search for exoplanets, it is difficult to rule out the possibility that alien beings exist beyond our planet. Although we do not yet have conclusive proof, discoveries and evidence suggest that the existence of extraterrestrial life is a fascinating possibility. What about the multiverse in relation to the vastness of the observable universe? Let me tell you, the possibilities are endless. The concept of the multiverse, also known as the many worlds interpretation, is a theoretical idea in physics and philosophy that suggests the existence of multiple parallel universes or dimensions beyond our own. The multiverse is mainly discussed in the context of quantum physics, which deals with the behavior of tiny particles such as atoms and subatomic particles. According to some interpretations of quantum physics, the act of observation can cause a quantum system to collapse into a single state. However, in the many worlds interpretation, the act of observation simply causes the system to split into multiple states, each representing a different outcome. It is important to note that the idea of the multiverse remains highly speculative and is not yet supported by conclusive evidence. It is therefore difficult to state with certainty whether it is a valid concept or not. Some scientists and philosophers find the idea of the multiverse intriguing and potentially useful in explaining certain phenomena, while others are skeptical about its validity. Given that we do not know what lies outside our universe, the possibility of the existence of a multiverse remains as valid as the famous Schrödinger's cat thought experiment or the nature of darkness. It is a concept that arouses fascination and reflection but requires more research and evidence to be confirmed. Does the phenomenon known as dark flow exist? The question is complex and raises an intriguing issue. Dark flow came about in 2008 as a possible explanation for the observation that some galaxy clusters appear to move faster than expected based on the distribution of matter in the universe. The concept of dark flow suggests that these galaxy clusters may be influenced by some form of dark matter or dark energy that pulls them in a specific direction. However, the existence of dark flow remains controversial and has not yet been accepted by the scientific community at large. Some studies have suggested that dark flow may be real and could be caused by the presence of a massive structure in the universe that exerts an attraction on galaxy clusters. However, other studies have failed to confirm the existence of dark flow and have proposed that the observed motion of galaxy clusters could be the result of other factors, such as systematic errors in the detected ones. While other studies suggest its possible existence, we cannot state with certainty its presence outside the observable universe. More research and evidence are needed to better understand this intriguing phenomenon. What do you think? Let us know in the comments box. Remember to like and subscribe, and see you in the next video. One of the greatest mysteries in cosmology is the nature of dark matter and dark energy. Together, they make up about 95% of the universe, with dark matter accounting for approximately 27% and dark energy making up the remaining 68%. Despite their immense influence on the structure and evolution of the cosmos, we have yet to directly detect either of these mysterious components. The future of our understanding of the universe is bright, and every discovery opens up new avenues for inquiry. The universe, with all its vastness and complexity, is a testament to the wonders of scientific exploration. Whether it's uncovering the mysteries of dark matter, detecting signs of alien life, or exploring the very fabric of space-time itself, the quest to understand the cosmos will likely continue to shape human history for generations to come. Will humanity ever reach beyond the observable universe? As we ponder the future of space exploration, a natural question arises. Will humans ever develop the means to travel beyond the observable universe? The idea, though currently far beyond our technological capabilities, is not purely science fiction. It reflects the boundless human curiosity to explore and understand what lies beyond the known. Currently, even traveling to the nearest star system, Alpha Centauri, would take tens of thousands of years using our fastest spacecraft. Escaping the gravitational bounds of our galaxy, let alone the observable universe, would require breakthroughs in propulsion, energy generation, and perhaps our very understanding of physics. One potential solution often discussed in theoretical physics is the use of warp drives, hypothetical systems that bend spacetime to achieve faster-than-light travel. Inspired by Einstein's theory of general relativity, concepts like the Alcubierre drive suggest it might be possible to compress space in front of a ship and expand it behind, creating a bubble that moves faster than light relative to outside observers. However, the immense energy requirements and unknown physical effects remain formidable challenges. Another speculative possibility is the use of wormholes, shortcuts through spacetime that could, in theory, connect distant points in the universe or even different universes. While general relativity allows for the possibility of wormholes, keeping them stable long enough for travel, and ensuring they don't collapse under gravitational forces, is still purely theoretical. Whether through these exotic means or entirely new physics yet to be discovered, our descendants may one day reach beyond our current cosmic horizon. The role of artificial intelligence in space exploration. Artificial intelligence, AI, is increasingly becoming a vital tool in our efforts to understand the universe. AI algorithms now analyze massive datasets from telescopes, assist in navigation for interplanetary missions, and even help identify exoplanets by recognizing subtle patterns in light curves. For instance, NASA's Kepler and TESS missions have benefited immensely from machine learning algorithms that sift through vast amounts of data to detect potential planets orbiting distant stars. Similarly, AI tools are being used to model galaxy formation, simulate dark matter distribution, and even predict cosmic events. As we build more advanced telescopes and space observatories, the volume of data will increase exponentially. Without AI, it would be nearly impossible to process and interpret all this information. In the future, AI could also assist autonomous spacecraft exploring remote regions of the solar system and beyond, making decisions in real time without relying on Earth-based commands.